Continuous exterior insulation is becoming a code requirement in many parts of the country, not just for the energy efficiency benefits, but for the durability benefits, as we can reduce the potential for condensation on the backside of our sheathing by warming it up with some rigid insulation. And this is a really big deal in colder climates to prevent mold growth and deterioration of our structural components. But how much exterior insulation do you actually need to get these durability benefits? As usual, it depends. Let's first take a look at the latest guidance from the 2024 IRC, the International Residential Code. This is yet to be adopted by a lot of states and jurisdictions, but it'll likely be adopted by the next cycle. Now let's first take a look at what's required for wood-framed wall assemblies. We should mention that in the IRC, you do have the option to omit continuous insulation if you achieve a higher R value inside the cavity based on these tables. The reason why this is potentially risky is that if you're building in a colder climate, it doesn't account for condensation control, and you could end up with some rotten sheathing if you don't insulate from the exterior or provide another means of condensation control. This is one of the main problems with just following the code tables. They often don't tell the full story. Now, you'll see at the top of the table, the columns are divided into climate zones, and as you go through each climate zone, you'll see that there are different requirements for continuous insulation, with the colder climates requiring a greater amount of continuous insulation since there are larger temperature extremes between the indoor and outdoor environments. So let's start with the climate zone 4 because this tends to be where we have actual winters and where we have a higher likelihood of seeing wintertime condensation problems. So based on this table, if you're in IECC Climate Zone 4, which is a good portion of the United States, especially on the East Coast, New York City, New Jersey, Southern Pennsylvania, Virginia, Maryland, that entire block, the code says that you need a minimum of R10 continuous insulation in combination with a minimum of R13 in the cavity for your wall assemblies, which is excellent and provides a lot of redundancy, even if you are operating at higher interior relative humidity levels. However, the code also says that you can achieve this with R20 in the cavity with R5 continuous insulation if you want to reduce the amount of continuous insulation in the assembly. This is also a pretty good assembly if you're installing that R5 continuous insulation on the exterior, but now the backside of the sheathing is more thermally isolated from the interior conditioned space. Now, this isn't a big deal in Climate Zone 4, where we only need 20% of the total R value of the assembly to be installed outboard for condensation control. But check this out. The same requirement applies to Climate Zone 5, Climate Zone 6, and Climate Zone 7 and 8. These are significantly colder climates than Climate Zone 4, especially as we get into Zones 6, 7, and 8, and if we use the wrong insulation strategy, we can actually see deterioration in our buildings. So what's going on here? The numbers in the code tables were actually based on research conducted by Building Science Corporation to determine how much insulation was required to reduce the potential for condensation, but they got altered to more easily satisfy the energy efficiency standards. Basically, the code allows you to compromise durability for energy efficiency, and if you don't know any better, you can run into some pretty serious problems. These are the unadulterated condensation control tables from Building Science Corporation that the codes are based on, and they actually look pretty different. Rather than applying a one-size-fits-all figure, you'll notice that the amount of exterior insulation increases substantially as we get into the colder climate zones, as they should since there are more potential condensation hours. So for Climate Zone 5, we need 30% of the total R value of the assembly to be installed as continuous exterior insulation or spray foam in the cavity, but for the sake of this video, we're talking about continuous insulation. And then for Climate Zone 6, we need 35% of the total R value of the assembly, and then Climate Zone 7 and 8, we need 45 and 50% of the R value of the assembly to be installed outboard as continuous insulation. This is all based on operating at 70 degrees Fahrenheit at 35% relative humidity. If you operate at a higher interior relative humidity, you need a greater ratio of outboard insulation to prevent condensation, since it's much easier for interior humid air to find a cold condensing surface. So if we use R13 cavity insulation plus R10 continuous insulation on the exterior of the assembly, that gets us to about 43% of the total R value of the assembly, which will work up through Climate Zone 6. We just need a little bit more to make it work in Climate Zone 7. It's completely inadequate for Climate Zone 8. Maybe they're hoping that no one lives in Climate Zone 8. However, if we use the option for R20 plus R5 continuous insulation, that's only 20% of the total R value of the assembly, and that doesn't doesn't work for climate zones 5, 6, 7, or 8, and in fact, it would place your building at a very high risk of moisture damage from condensation. And that's where we have discrepancies between the actual research and what has actually been written into the code. We need to go above the code minimums in certain climates in order to achieve a moisture-safe building. We actually discussed this in depth in our brand new continuous insulation course, designed specifically to help you navigate these new continuous insulation requirements and learn how to integrate continuous insulation strategies successfully for a wide range of building assemblies so that you can have a durable, long-lasting home or building. Go and take our free training and get 15% off the course. No commitment necessary. We just ask for an email. Become the expert that your team needs you to be. Links are in the description below. We have the same problems with unvented roof assemblies as well in the code. Let's go over to table R806.5, insulation for condensation control for unvented attics and enclosed rafter assemblies. The code states specific R-value figures based on the climate zone of how much continuous rigid insulation should be installed outboard for condensation control, and the obvious problem with this is that it should be a ratio or a percentage rather than a number, but they didn't want people doing the actual math. Now, these numbers work for the most part if you don't exceed R49 in your roof assembly, and if you aren't operating at high interior relative humidities, but a lot of the northern states require R60 to be installed in the roof assembly, which completely throws off these numbers stated in the code because the code doesn't follow the ratios. For example, in Climate Zone 6, the IRC calls for a minimum of R25 to be installed outboard, but if a specific state requires R60 to meet code, that only gets you to around 41%. You need a minimum of 50% of the total R value to be installed outboard. So moving forward, we want to reference the condensation control ratios that the code is based on rather than the code minimums if we want to protect our buildings from moisture problems. Remember, the code is the worst possible building that you can construct by law, and if you want a durable and comfortable home that will last a long time, we need to know when to go above and beyond the code. If you found this video helpful, make sure to leave a like and subscribe for more weekly building science videos, and head over to our website at asiri-designs.com where we have over 150 free building science articles that cover a wide range of topics. Links will be in the description below. For now, good luck with your projects. Cheers.